Good evening, everyone. I welcome you all to the PMRF Symposium 2021, Day 3. Today, we have 6 presentations. I'll start with the first presenter, Anandaru.
Hello and welcome to my presentation. I am Anandaru and I am pursuing doctoral research at the Department of Civil Engineering, IIT Madras, under the guidance of Professor Parishi Pradeep Pratapa. Today, I'll talk about the mechanics of origami-based lattice structures and the possibility of wave propagation in such lattices. This is a brief overview of topics I'll be covering in this talk. Wave propagation demands a medium with multiple degrees of freedom. Conventional Muraori with rigid panels has a single degree of freedom and cannot allow wave propagation. So researchers chose to model origami with non-rigid panels and succeeded in designing origami lattice metamaterials with elastic wave band gaps. However, the non-rigid panels allow for stretching deformations that resulted in origami lattices with band gaps but at very high frequencies, unsuitable for typical engineering applications. To overcome this issue, we choose to split parallelogram panels diagonally into two rigid triangular panels, and thus obtained multi-degree of freedom origami lattices with purely folding-based deformations without any stretching. We term this rigid triangulated Muraori or RTM. Coming to overall objectives, origami metamaterials are artificially architected foldable lattice structures with exotic properties. If we can successfully establish the presence of low frequency elastic band gaps in origami lattices, our research will be the first in the world to show the potential use of origami metamaterials for wave propagation based applications such as waveguides and vibration isolation. These are relevant in various fields of engineering like civil, mechanical, aerospace, etc. So we plan to conduct theoretical and computational study focusing on linear elastic analysis of thin rigid panel origami within small deformation limits. We will look at both 1D and 2D tessellations as shown here, and we will draw insights from both finite and infinite lattices of rigid triangulated Muraori. Our study of the mechanics of RTM lattices begins with outlining the parameters that govern the geometry of each lattice, both 1D and 2D tessellations. Next, we branch out in two major directions, statics and dynamics. Our work in statics started with establishing equations of compatibility and identifying effectively independent degrees of freedom that lead us to kinematically admissible deformation modes. We proceed to derive the stiffness matrix based on an elastic potential energy formulation. Under dynamics, we start with kinetic energy and proceed to Lagrange's equations of motion to finally derive the mass matrix. Plugging in the block wave reduced mass and stiffness matrices into a generalized eigenvalue problem gives module frequencies for each wave vector, and a band structure is revealed when these frequencies are plotted across a range of wave vectors. A band of frequencies where no deformation modes exist is then identified as a band gap. Wave propagation is inhibited in this frequency band. Spherical trigonometric relations allow us to develop equations of constraint between folding angles measured at the creases. The isolated degree 6 vertex is an intersection of 6 crease lines and has 3 degrees of freedom. By tessellating along the x and y axis, as shown here, we eventually find that the kinematics of 1dx and 1dy RTM lattices can be modeled with effectively 4 degrees of freedom per unit cell. In order to verify the number and shape of independent deformation modes in folding angle formulation, we chose to alternatively model the 1D lattices with the bar and hinge framework, where planar panels are replaced with stretchable truss members along the edges. Each unit cell has 6 nodes, each with 3 displacement degrees of freedom, that is 18 degrees of freedom per unit cell. The compatibility matrix C relates the vector of bar extensions E to the vector of nodal displacements U. However, if panels are rigid, bar extensions are 0. So all kinematically admissible solutions must satisfy Cu equals to 0. For an infinite lattice, the compatibility matrix is also infinite in extent. However, assuming a periodic deformation mode across the lattice, the infinite matrix can now be reduced to the size of the unit cell, and null space of this matrix gives us 4 independent modes for any wave vector parameter W, supporting our findings from FAF. Our study confirms the presence of 4 inhomogeneous modes for any chosen wave vector in infinite 1D RTM lattices. Shown here are the representative deformation modes plotted over 7 unit cells for each of the 4 modes of 1dx RTM lattice for its chosen periodicity as shown here. Similarly, here are representative deformations for each of the 4 modes of 1dy RTM lattice plotted over 7 cells with the same periodicity. Assigning rotational stiffness to the creases, energy can be calculated for an elastic perturbation from equilibrium. For both 1dx and 1dy lattices, we plotted elastic energy against wave vector parameter W calculated for each chosen mode using an existing bar and hinge formulation and the proposed folding angle formulation. The 4 colors in each plot represent the 4 different deformation modes. An exact match in energy from both formulations confirms the consistency of our modeling of rigid panel origami across the frameworks. "2D Murari sheet folds uniformly as a single degree of freedom system. However, 2D RTM allows for a saddle and twisting mode in addition to planar folding. Till this point in literature, we had only homogeneous deformation modes in 2D origami, and therefore no wave propagation. But now, in addition to all the homogeneous modes, we see a 2D origami sheet exhibiting a wavy or inhomogeneous deformation mode with a finite periodicity or wavelength. How is this made possible? This is attributed to the enhanced freedom owing to the presence of voids in a structure formed with interconnected 1D strips. This is proof that 2D RTM with interconnected strips allows wave propagation. We conclude that 1dx and 1dy as well as 2D lattices with interconnected 1D strips exhibit inhomogeneous deformation modes that allow wave propagation. Deformations in rigid panel origami are guided entirely by folding at creases, hence the proposed folding angle formulation captures kinematics of RTM lattices more efficiently and with fewer degrees of freedom. Verification of the folding angle formulation proposed here with the existing bar and hinge formulation confirms the authenticity of our findings. Since folding deformations at creases are typically associated with lower energy, our research shows the potential for use of origami lattices in low frequency wave propagation based applications like acoustic metamaterials and waveguides. We have already developed a novel analytical formulation for linear elastic analysis of thin rigid panel origami within small deformations. We shall compare our formulation to the existing and widely used bar and hinge framework. We also plan to verify our findings with finite element simulations and proof of concept type prototype experiments if possible. We can roughly divide our deliverables into the following segments, dealing with statics and dynamics of 1D and 2D RTM lattices. The current state of progress in each direction is as shown below. Here is a detailed plan of our present and upcoming publications over the tenure of my PhD research. We also have a publication in the proceedings of the ASME IDETCCIE conference 2021. This is the timeline of my PhD research journey with tentative dates for important milestones. Here are a few of my important references. Thank you for your attention, and we will be happy to answer any questions. You can also contact us on email. Thank you.
Thank you, Anandru, for this nice presentation. Now the floor is open for queries. The participants can post the questions in chat box, or you can unmute yourself and ask the questions.
Hello, Anandru.
Hi. Hi,
I'm
Shivpurna.
Shivpurnan. Yeah. So very nice presentation.
Thanks.
I just have a question on what is the motivation of having to study RTM, rigid origami structures, when in reality we don't have anything rigid, right? So,
right.
Why do we have to consider such structures, and what is the motivation behind it?
So ideally in origami structures, we see structures which are primarily folding. So there is hardly any stretching that is actually happening in the panels. And even if that is happening, that is very, very negligible. So we don't expect stretching or such deformations, distortions within the panel to actually influence the energy dynamics of the system. So ideally, we should actually take that to be rigid in our theoretical formulations. So that is why it also simplifies our work. It reduces the degrees of freedom, increases computational efficiency, and at the same time, we just get very low frequency energy behavior, the low frequency dynamics of the lattice, which we wouldn't get otherwise. Does that answer your question, Shivpurna?
Yes, Anandru. Thanks for the explanation.
Thanks for your question.
There's a question in the chat. For rigid origami structure, require hinge connection. How and which type hinge will be provided?
Right. So that we plan to conduct prototype experiments if possible in the future after our theoretical formulations are complete, and we are currently still thinking about that, and we think a kind of some kind of compliant mechanisms will be useful, like maybe using perforated joints. We are not yet sure. Some kind of elastic material that is much more flexible than the one that is used in the panels is ideally what we are looking for. So if anyone else has an idea, we would be welcoming your ideas also. Abhishek.
Abhishek, you
Yes.
can unmute yourself.
I'm just asking the question. I am not solution.
Right. Okay. Yeah. Fine. Yeah. Currently, we don't know what is the ideal way to do it, but we are still looking at it.
Okay. It means research field is going on there. Okay.
Yeah.
No problem.
Yeah. Very few experiments are happening worldwide, and most of them are still trying to figure out what to use perfectly for compliant origami joints, and to get this kind of behavior where the panel appears perfectly rigid compared to the compared to the joint, the crease.
Okay.
Hey, Anandru, Kumar here. Nice presentation.
Hi.
Yeah, I just want to have a quick question. Like you told about linear elastic analysis with small information. Like also there won't be any large information, and like
Right.
don't you expect any non-linearity other than geometrical?
Exactly. Yeah.
Okay, so there won't be any other non-linearity geometrical. So you are sure that you won't encounter in large deformations?
It's not about us not encountering large deformations. It's we want to analyze the structure. There are two reasons. First of all, we want to analyze the structure with all the parameters at the unperturbed equilibrium state, like we do in structures, assuming small deformations. If we have nonlinearities, that is not part of our analysis, and we don't want to go into second order effects and stuff. And the second part of it is if we do go into, I mean, um, such large deformations, we don't know how nonlinear it will behave and how we can simulate that in experiments and stuff. So we don't look at the large deformation behavior right now.
Okay, thank you.
Anandrup, Shivapunan again. So, what is the motivation for why origami? Why origami for this band gap applications?
Yeah. So why origami is because with origami we get a certain set of advantages, like you would also know. So with origami we get tunable structures. So if we get a solution, a design solution such that it has interesting band gaps and frequency ranges with desired, then such solutions will also be tunable and programmable, which means tunability is that we can change the behavior of the structure with respect to its own geometrical parameters that it chooses with respect to the folded state. And programmable means its panel length, its own the panel angle and everything can be modified such that at the design state itself we can get a range of a range to play with in the design properties. So, which very few other metamaterials or even other conventional materials give us that option. So that is the general advantage why origami is attracting a lot of attention in research right now, all over the world.
Okay, thank you. And when do you see that this can be? When do you see this to be in practical application? How much time do you think it will take before we can see such things in practical applications? And what can be the practical applications?
Yeah, that is an interesting question. With origami, we see a lot of practical applications right now based on the last 10-15 years of research, but not yet
Yes,
so much in
especially
the
in the area
dynamics.
that
Yeah.
yes, dynamics and band gap area.
Yeah, so hopefully soon we want to establish something that is giving us a kind of metamaterial which does that, which has interesting band gap properties. Uh, Till now, not a lot of work has been done in that area, so we are still going to go into the experimental things and verify our findings if possible, and then probably within another 5-7 years it should be there, hopefully.
Okay, thanks.
Thanks. I think Gaurav.
Anandru, yeah, I have one more question.
Yeah. So thanks, Gaurav. Plan to keep that.
How you theoretically plan to keep the integrity of the hinge while the high frequency wave passes through the structure?
Right. So assuming that the structure allows low frequency waves to pass, right? Like, is that the idea?
Yeah,
if we
and
have,
like for low
yeah.
frequency, it is fine. Like if there is a case of high frequency, do your study, the scope of the study include that also?
Yeah, high frequency waves, like you mean like it will cause large distortions within the structure, right? Within the panels or something.
Yes.
So we don't think our structure should be responding to such high frequency waves because with folding you can only access the lower frequency dynamics part of the thing. So we don't expect the panels to distort because of that.
But is it the scope restricted to low frequency? Like
yeah, that's what.
Okay.
Yeah. So since our structure behaves, all of the modes of the structure will be in the low frequency range. So we don't expect the structure to respond dynamically in the high frequency excitations. Yeah, does that answer your question, Gaurav?
Yeah. Okay.
Thank you, Ananduru. If the questions are over, we can move to the second presentation of the day.
Thanks.
Let's move to the second presentation of the day. It's by Onkar Ekande.
Good evening to all. I am Onkar Ekande, working on removal of emerging contaminants from wastewater using photocatalysis under the guidance of Dr. S. Mathava Kumar. So, emerging contaminants include pharmaceutical and personal care products, fire retardants, and pesticides. Talking particularly about the pharmaceuticals, India is a hub for this production of pharmaceuticals and consumption of the pharmaceuticals. This pharmaceutical consumed by the humans enters into the sewage treatment plant through the urine and feces in the form of parent compound and metabolites. These pharmaceuticals present in the wastewater in the low concentration. These conventional biological treatments units are not sufficient to degrade this pharmaceutical due to their aromatic recalcitrant structure. Uh, these pharmaceutical pose a great threat in terms of antibacterial resistant genes, antimicrobial resistant genes, and their chronic toxicity. The different studies were conducted earlier to understand the removal of pharmaceutical in terms of biodegradation and sorption in the secondary treatment units. So for this activated sludge process, you can see that the different classes of pharmaceuticals are uh, reported with the consider, considerable variation in their removal percentage, which depends on the characteristics of wastewater, which varies with the season. So, additional treatment process is required to degrade these emerging contaminants. For this, we required a high uh, redox potential generation. We required to generate high redox potential radicals like hydroxyl radicals, sulfate radicals. Uh, These reactive oxygen species based AOPs, where these hydroxyl radicals are a major and highly reactive radicals. This photocatalysis, ozonation, and phenton process were performed to form this ROS. Sulfate radical based AOPs are recently get attention due to the high uh, redox potential of sulfate radicals. This per sulfate activation was done for this generation of sulfate radical in both presence and absence of the light. Another AOPs are like per acetic acid activation, reactive chlorine species generation, and reactive nitrogen species generation. As you can see here, this hydroxyl radicals is having highest redox potential, followed by the sulfate radicals, ozone, and hydrogen peroxide. Different electron acceptors were present in the photocatalysis, which reduce the electron hole recombination and form these radicals. So the oxygen is widely used electron acceptor due to its non-toxicity, whereas persulfate, if you see this redox potential, persulfate is reduced at 1.44 volt versus normal hydrogen electrode, which is higher than the oxygen and hydrogen peroxide. So we can say that persulfate can be easily reduced to form the sulfate radicals compared to the oxygen and hydrogen peroxide reduction to form the ROS. So moving towards this persulfate activation, different external energies were used for the generation of radicals. As you can see, the persulfate salt is used as a source for this sulfate radical generation. This peroxymonosulfate and peroxydisulfate are the two salts. You see here in this reaction that this peroxymonosulfate and peroxydisulfate itself, they are good oxidants, but their kinetics of the oxidation is very slow, so we required external energies to increase the to break these oxygen bonds present in the structure of these two salts to form the two sulfate radicals in case of peroxy disulfate, and one sulfate radical and one OH radical in case of peroxy monosulfate. You can see here this peroxy disulfate is having pK value of -1.3, which suggests that it present in SO2 S2O8 minus form, whereas peroxy monosulfate present in SO52 minus form above pK 9.2 and HSO5 minus form below pH 9.2. Whereas this peroxide monosulfate is having high oxygen-oxygen bond dissociation energy compared to H2O2 and PDS. Another persulfate activation is done by using carbocatalyst. This composition contains predominantly carbon. These are the carbon nanotubes, graphene oxide quantum dots, activated carbon, and graphitic biochar. This is done without light through the different processes like the generation of singlet oxygen and electron transfer. Moving towards this photocatalytic activation of persulfate, where different photocatalysts were used, such as TiO2, carbon nitride, zinc oxide, which are reportedly used for this activation of persulfate. Where this you can see photocatalyst in presence of light, electrons from the valence band goes to the conduction band, where hole is generated at valence band, oxidize the H2O to form the OH radical, and electron present in the conduction band reduce the persulfate to form the SO4 radical. Different transition metals are also reportedly used for this activation of persulfate. Now different photocatalysts, moving towards the our main objective of the work is to use photocatalyst for this persulfate activation. Different photocatalysts are listed here, which are used for this treatment of emerging pollutant. For this particularly the application of persulfate, we want the photocatalyst with the high position of the conduction band, so that it can easily reduce the persulfate to form the sulfate radical. TiO2 from in this table you can see this TiO2 carbon nitride zinc oxide is in high conduction band compared to, but this TiO2 and zinc oxide, they have the high band gap which can be activated in the UV light. Comparatively carbon nitride with a low band gap of 2.7 we can activate in the visible light. So moving towards this carbon nitride as a catalyst, it is chemically inert and resistant to the electron transfer, whereas different precursors, low cost precursors were used for this thermal polymerization generation of this graphitic carbon nitride. Melamine is a widely used precursor because of high yield, around 40%, for this formation of graphitic carbon nitride. But the major drawback of this carbon nitride is a low specific surface area, low efficiency in visible light, and high electron hole recomposition. So I worked on this improving the specific surface area and check the activity with respect to increase in the specific surface area. We found that we synthesized this carbon nitride with the pre-treatment of this melamine with the acetic acid, and which form this acetic acid modified carbon nitride, which is denoted by ACN. As you can see, it is slightly pale yellow color compared to the pristine uh, carbon nitride form without acetic acid pre-treatment. At the scanning electron microscopy, you can see this ACN is having porous structure compared to this GCN, and around 5%, 5 times increase in the specific surface area. X-ray diffraction graph shows these characteristics carbon peak between around 27 degree both for GCN and ACN, which can conclude that this acetic acid Pre-treatment is not disturbing the structure of the carbon. So to check the per-sulfate activation ability and compare, we take a model pollutant, a metronidazole antibiotic, which is a imidazole antibiotic, and we, as you can see here in this experimental setup, 3 blue LED lights with a 15 volt each and 500 ml of solution where with a 10 mg per liter of MAT and 1 gram per liter of the prepared catalyst were take. So you can see in this kinetics graph, this ACN is having very good efficiency compared to the pristine carbon nitride and almost 1.5 times increase in the removal rate of this carbon nitride. As ACN is having valence conduction band around minus 1.25 volt, which can easily reduce this per sulfate to form the sulfate radical, whereas the holes generated which are not able to oxidize water can directly, due to their low redox potential, can directly oxidize the MET to form the byproducts and CO2. Moving towards the scavenging and competitive ion study to understand the formation of sulfate radical and effect of water and ions on this removal, we found that the reduction in this removal of MET in presence of ethanol, which is the scavenger for the sulfate radical, whereas this formic acid as a whole scavenger reduce the removal by around 10 to 15%. So we can say that the sulfate radical is the major reactive species and the holes are the minor reactive species in the removal of metronidazole. Coming towards this anion study, carbonate presence affect most due to their scavenging effect to the sulfate radical, and this removal is reduced around 30%, whereas the nitrogen is the least affecting, which is in presence of nitrate around 80% removal of MET was observed. So this is the degradation pathway of MET. The different metabolites are formed and during this degradation of this MET during the photocatalytic per-sulfate activation process. So conclusion is this acetic acid modified improved the photocatalytic activity of carbon nitride, where model pollutant was completely removed within 300 minutes. As I am saying completely removed, it is the parent compound, not the all metabolites. Then pre-treatment with the acetic acid improves the specific surface area, which helps to improve the activity of this carbonate. And the carbonate has played a major role in the scavenging of sulfate radicals. So these are the visible outputs. Thank you.
Thank you, Anka. Now the floor is open for queries. The participants can unmute yourself and raise your questions.
Hello, Onkar.
Yes.
My name is Shivapurnan.
Yes.
So actually, being out of this area, I couldn't understand much of your work. But can you please summarize your motivation for research and the main contributions in a couple of lines for our benefit?
Yeah. So actually, the motivation of work is regarding currently the situation. We are taking a lot of drugs, antibiotics daily for different purposes like blood pressure, diabetes, fever, and all. So actually, the thing is, this dose, like you hear that we take when we ask chemist for 500 mg like a paracetamol or crocin and all. So this dose we took, but it is not completely utilized by our body, and the remaining part of that drug is going to the wastewater through our urine and feces. So what is happening? Like in wastewater treatment plant, we have activated sludge process and any other biological treatment process for this degradation of BOD and COD. Along with that, they try to degrade these compounds, but due to their aromatic structure, this aromatic ring is difficult to break by these microorganisms. So what is happening? These pharmaceuticals are going into the river bodies. So what is next is through this river, they are again coming into the drinking water. They are going into the through irrigation. They are going into the farms. So what is the thing that is happening is we are taking this pharmaceutical in very low concentration on daily basis through our drinking water. So what will happen in future, like 20-30 years from now, if we are taking, suppose we are taking crocin daily without having fever. So 20-30 years, after 20-30 years, if you have a fever and if you take or anybody take a crocin, it won't work because our body is now adjusted to that crocin. So that fever and all, no. So the like pre-vaccination era where people used to die by fever, this will happen in future. So another thing is like chronic toxicity in terms of this liver and kidney, they are also getting damaged because if we are taking a daily dose of pharmaceuticals without having any with a healthy person also taking this dose. So that is why currently the more focus is going on this emerging contaminants removal, like a situation like COVID and all, where we are taking a lot of drugs for this fever and all. So it will be a very alarming situation. Recently also you heard in this newspaper, this IIT Madras team found lot of pharmaceuticals in the Kaveri river. So that is the motivation that to degrade these pharmaceuticals.
Thank you, Ankar. It was it's really a very interesting topic. And can you also summarize your research and what you are working on? Like, what are you trying to address the problem on? Which part of the problem are you addressing?
So my objective is to prepare the different materials, like different photocomposites, so that it will form the different radicals, and it will radicals is having high oxidizing potential, so they can oxidize these aromatic compounds, and it will be they can mineralize, not just suppose there is two aromatic rings in the one compound. If it removed both one aromatic ring, then it may be possible that parent compound with the two aromatic ring is low toxic, but the metabolite which is formed after degradation is more toxic. So our interest is to completely mineralize, like a CO2, forming CO2 and like lower molecular compounds which are not toxic.
Okay. Thank you, Ankar.
If no more questions, we can move to the next presentation of the day. The third presenter is Urban Raj.
Hi everyone, myself Arbin Raj, a PhD research scholar from the Department of Civil Engineering. My research advisor is Dr. J. Murali Krishnan. Today, I am giving a talk on my research topic, investigations on the inhomogeneity and anisotropy of bituminous mixtures. The presentation is designed as follows. First, I will start with the introduction part. As shown in this figure, a typical bituminous pavement consists of 4 to 5 layers, in which the top 2 layers are constructed using bituminous mixtures. In this research, the main attention is given towards this particular mixture. Bituminous mixture consists of different size aggregate particle binded with asphalt binder. It is well understood that bituminous mixture exhibit viscoelastic response. That is, they respond dependent on two factors, temperature and frequency. A typical bituminous pavement design procedure followed linearized layered elasticity theory, in which the material parameters are elastic modulus and Poisson's ratio. Since bituminous mixtures are viscoelastic in nature, we need to use a modulus value which is dependent on the frequency of loading. Therefore, we will use some modulus which called as surrogate modulus. Different countries use different kind of modulus such as dynamic modulus, flexural modulus or resilient modulus. However, estimation of such modulus value are based on the assumption that bituminous mixtures exhibit homogeneous and anisotropic characteristics. However, it is not sure that how far these assumptions hold good. Moving more detailed into the estimation of different modulus values, dynamic modulus was estimated at a temperature range varying from 0 to 60 degrees Celsius and a frequency range varying from 25 to 0.01 Hertz. However, in the case of a flexural modulus estimation, the test was carried out at 20 degrees Celsius at 10 Hertz frequency. In the case of resilient modulus, the temperature is 25 degrees Celsius and the frequency is 1 Hertz. The main thing to be noted in this is the direction at which the deformation were captured. In the case of dynamic modulus test and the flexural modulus test, the deformations were captured only in one direction. However, in the case of a resilient modulus test, the deformations were captured in two directions. That is, deformation across the vertical direction as well as the horizontal direction. One interesting fact to be noticed that the deformations were captured not only in one phase of the sample, the deformations were captured in the opposite phase of the sample. So ITT mode of test, which is preferred for resilient modulus estimation, gives better deformation or response of the material for further investigation. In addition to the material parameter, one another important detail which need to be understood in the design of pavement construction is the distress occurred on the pavement. There are two major distress which is observed on the bituminous pavement. One is the fatigue cracking, which occur at a lower temperature of 20 degrees Celsius, and rutting occur at a higher temperature of 60 degrees Celsius. There are different laboratory estimations to evaluate the fatigue and rutting. For 20 degrees Celsius fatigue cracking is estimated using a tension compression test or a beam bending test. However, in the case of rutting, one can use float time or float number test or rut wheel test. But one thing we need to notice that a typical bituminous pavement in Indian condition is designed as an annual average pavement temperature of 35 degrees Celsius. But we are estimating the distress at 20 degrees Celsius and at 60 degrees Celsius. But what about the distress occurred in between these two regions, that is between 20 degree and 60 degrees Celsius? So that is one unexplored area till now. Looking into the distress or the failure of other materials such as stainless steel, the distress can be shown as follows. At higher strain level, creep failure is occurred, and at lower strain level, fatigue failure is occurred. There is a region in between creep and fatigue failure, which is termed as creep fatigue interaction. When coming back to the bituminous pavement, at lower temperature, the residual strain will be lower, and at higher temperature, the residual strain will be higher. So there exists an intermediate region. So is there any creep fatigue interaction can be observed in the case of bituminous mixture? This research will investigate this aspect also. So to address all these issues, we are planning to choose indirect tensile test for in this research. Why indirect tensile test? In indirect tensile test, the deformation capture or the material response can be captured in different direction and different orientations. However, there are few challenges in this test method. One is the choice of gauge length. One can capture the response by fixing the LVDT in the horizontal and vertical direction, and the deformation under consideration will be 1/2 of the diameter of the specimen. However, in the case of a quarter gauge, this deformation can be considered only 1/4 diameter of the specimen, which is termed as quarter gauge length. So, it is necessary to investigate the influence of gauge length with respect to the deformation captured as well as the input load levels. When the gauge length changes from half to quarter gauge, the deformation may or may not vary. This aspect need to be studied. Another challenge in front of this research is that it is a delineation of linear non-linear limits for bituminous mixtures in biaxial testing mode. In the case of one-dimensional experimental data, linearity or non-linearity can be established using superposition and scaling principle. However, it is not sure that such principle will work for a biaxial experimental data. Concluding all these facts, the objectives are presented as follows. First, the linear viscoelastic limits for a biaxial experimental data need to be established. Once it is established, one can choose a suitable linear or non-linear viscoelastic model, and using the model, the response of the material can be obtained. And this test can be carried out at ITT mode because the deformation can be measured at 90 degrees as well as at 45 degrees. This deformation data can be used to identify the extent of inhomogeneity and anisotropy of the bituminous mixtures. Finally, an investigation into the creep fatigue interaction of bituminous mixtures can also be carried out. These are the likely deliverables in which the nonlinear or linear limits of bituminous mixtures in biaxial testing can be estimated, and a relic into the anisotropy and inhomogeneity of bituminous mixtures, and the time-dependent viscoelastic Poisson ratio and corresponding modulus value will be estimated. And finally, the development of a new test protocol to quantify the creep fatigue interaction. The scopes are listed as follows. This is the methodology adopted for this research work, in which an ITT test is carried out at 5 different temperatures and using one unmodified binder. Using the experimental data, linearity is established, and this data is used to capture the extent of inhomogeneity and anisotropy of the bituminous material. And finally, using a suitable linear or non-linear viscoelastic model, the material properties were evaluated, and finally, the material damage was studied. This is the glimpse of ongoing research work in which the ITT tests were carried out at 3 different frequency and 3 different load level at 20 degrees Celsius using 2 different gauge lengths. The analysis part consists of estimation of steady state and the estimation of material parameter. Estimation of material parameter is carried out at 2 different ways. One is ASTM D7369 method, and one is based on a linear viscoelastic model, which is explained in the next slides. Estimation of material parameter using ASTM D7369 method, Poisson ratio and resilient modulus equations were given, and it is straightforward considering the material is elastic in nature. However, it is understood that the material is linearly viscoelastic, and we are considering a linear viscoelastic model, which is a combination of 2 Kelvin-Fock units and 1 linear spring attached in series. There are 2 cases discussed in this. In the first case, we assume that Poisson ratio is a constant. So we will took the Poisson ratio from ASTM D7369 method, and using the Poisson ratio, and we will guess the initial 5 parameters, we will fit the horizontal deformation. And the resultant parameter were used to predict the vertical deformation. In the second case, we will consider viscoelastic Poisson ratio as a fitting parameter, and initial guess for the 6 parameter will lead to the fitting of the horizontal deformation, and the resultant parameters were used to predict the vertical deformation. These are the equations for equation 1 represent the horizontal deformation and 2 represent the vertical deformation, and using the estimated parameters as followed in equation 3, we will get the creep compliance. From the creep compliance, we can compute the modulus value. These are the few plots which is used for fitting the experimental data. These are the important milestones in this investigation. First of all, we'll need to establish the linearity limit. Based on that, we can estimate the material parameters, and extent of anisotropy and inhomogeneity, finally a reliquidity creep fatigue interaction. These are the planned publication in which the first one is under process. Thank you.
Thank you, Arvind, for this nice presentation. Thank you, Arvind, for this nice presentation. Thank you, Arvind, for the nice presentation. Now the floor is open for queries.
Hello, Arvind.
Yeah.
I'm Shivapurnan.
Okay.
It was a nice presentation. Thank you for the good presentation. I have a couple of questions. In one of your objectives, you had mentioned that you're going to estimate or quantify the amount of inhomogeneities in the material, right? So, how do you quantify the inhomogeneity, like in the sense of what scale, like a value you would assign based on how much inhomogeneity is there in it? And the continuation part is, doesn't homogeneity depend on the scale? For example, we might say that concrete is homogeneous in one scale, where it is inhomogeneous in a smaller scale, right? So depending on which scale we see that quantification number that you're going to give will also vary, right? So how are you going to incorporate that into the formulation?
Thanks, Shiva. So first question is like how to quantify the inhomogeneity or homogeneity. So basically, the ITT test having the capability to get the deformation data in different spatial location of the sample. As shown in the diagram, the deformation data can be collected in two different phases, and we can even loading into the other directions of the sample, and again we can collect the deformation data. So using those deformation data or the response of the material, we can create one deformation map kind of thing, and from that we can proceed into the inhomogeneity or homogeneity aspects. As of now, it is not further explored or not studied in bituminous mixture. So I need to see the experimental data first. So then only I can tell further more details regarding the stream, even in the case of scaling also.
Okay. Once this thing comment is that have you gone through one of our works in here? I think Pratyush from our lab is also working on quantifying homogeneity, or how do we measure strains and gauge lengths, find out gauge lengths for an inhomogeneous mixture. I think it might be relevant to you too. So that's just a comment. And another question that I had for you is that Poisson's ratio you had said, right? So how do we define Poisson's ratio for a viscoelastic material? For example, if we have the deformation imposed along one direction, let's say along x direction we are imposing a deformation, along y it keeps continuously changing, right? Since it's a viscoelastic material. And how do we impose that x itself? In what rate did we impose that x itself will influence the y, right? The deformation in the y direction, isn't it? So the Poisson's ratio will depend both on how this deformation is imposed as well as time.
Yeah, so basically, as of now, what I'm planning is like, we have the preset equation for elastic solutions, so that I can use the correspondence principle to shift to the viscoelastic base. So that using that, I can compute the Poisson's ratio. That's what currently I'm planning for this.
Okay, but in general, I'm just trying to understand how do we define it? Like for elastic material is very easy to understand, right? For any given deformation along the longitudinal, what is the lateral strain we take? And since it's instantaneous, we can just take the ratio of them and take negative of it to find Poisson's ratio. But in a viscoelastic material, let's say I have viscoelastic material, what should I do to find it out? Like, can you try to explain in a simpler words so that I can understand?
So you're asking what kind of equations you can use or something like that.
Not exact equation, but how do we measure it? Like just
Yeah.
to get a practical feel of it. Since it
Okay.
keeps changing, I'm not able to understand how will it be the Poisson's ratio? Will it be a graph or
Yeah,
what
it will
exactly?
be. Yeah, so it is
Graph
like
and then what are the axes?
yeah, the first of all, how I am planning to do is like we have the external data like strain, means deformation versus the time of number of cycles. So using the data, I can fit some model. Using the model, we can estimate the material parameters rather than going into like simple stress, means lateral straight longitudinal strain kind of equation. I need to consider something like that.
Okay. Okay, thanks, Arvind.
Thanks, Ivan.
Hi, Arvind, Anilkumar here. Nice presentation.
Thanks.
I have a question. Like you said, you want to develop a test protocol for creep fatigue interaction.
Yeah.
Like, so what's like the current status of that one? Like, if someone want to investigate, like, what is new in establishing the protocol? Like, still in the
As
same.
as of now, there is no such protocol exists for bituminous mixture. So this is just an insight. Like we found that means we are aware that the fatigue cracking will happen at 20 degree, and at higher temperature cracking will be occurred. So there must be a interaction between these two in the intermediate temperature. So that is not yet explored, but in other materials, you can see such kind of interaction between creep and fatigue. So we are, with that insight only, we are looking into that as a last objective in this research.
Okay, yeah, but how much it is important, like, to investigate that one? Is it really important?
The thing is like as of now in current Indian design practices, the payment is designed as 35 degrees Celsius annual average payment temperature. There's a payment is subjected more into that particular one. So we may need to consider the type of distress. We can't stick into only one distress like a lower temperature or higher temperature. We may need to really look into what happened exactly in between those temperatures, especially the payment is designed for a temperature of 35 degrees Celsius.
Okay, yeah, thank you.
Thanks, Andy.
If no more questions, we can move to next presentation of the day. The next presenter is Sandeep.
Hello everyone, I am Sandeep from Department of Civil Engineering. I am here to present on my research topic, torsion of bituminous materials. Bituminous payments are designed and characterized based on the traffic loading that is occurring on the pavement. When we consider the type of traffic loading on the pavement, generally and traditionally, only the vertical load transfer from the tire to the pavement at a contact area is considered for the design of the bituminous pavements. But there are also certain traffic maneuvers which are acceleration and deceleration, which causes lateral shear traction and longitudinal shear traction on the surface of the pavement. These also leads to certain distresses on the pavement. One should actually consider the combination of both vertical load and also the horizontal tractions occurring on the pavement for the further design of the bituminous pavements. All these traffic loadings on the pavement will result in a three-dimensional state of stress within the layers of the pavement. There are certain test methods which only work on loading vertical loading conditions for the design of the pavements. The shear consideration is only done for the asphalt mastic, but there are no test methods which considers both the vertical load and also the shear load. When we look at the traditional, all the bituminous material characterization and its loading conditions, bituminous mixtures are generally characterized in compression, which gives rise to the dynamic modulus for the design of the pavements and also the master curve. But it is also used for the studying of distress, which considers the flow number and flow time. And there are also certain test method which applies both tension and compression, and it results in a certain kind of modulus, and also used to help in distress characterization, fatigue distress characterization. And there is 4-point beam bending test, which studies on the flexure and it gives us the flexural modulus, and also it is most like a damage test method which gives us the fatigue damage. But there are no test methods or design criteria based on the torsion, where in case of torsion, each of every cross section of the material is subjected to shear. There are no test methods available for distress characterization as well. In this research, I am focusing on using torsion of bituminous mixtures for the further characterization of the material and also the design of the pavements. For this research, a dynamic shear rheometer is used for the characterization. There are certain challenges when we wanted to use torsion of bituminous mixture. The first and foremost challenge would be depends on the size of the sample. When we have a size of sample of very big, we will not be able to apply torsion. So one should actually scale down to a smaller size and make sure that it represents the exact mixture sample or a representative sample. And once we apply torsion on the sample, one should ensure there are no forces on the outer surface of the sample. And there are certain linear and non-linearity based on the normal forces that are applied during shear. One should also consider that and understand whether it is linear or non-linear, whether the influence of normal force is creating a drift between the linear and non-linear viscoelastic properties of the torsion. Based on the following background, I have formulated 3 objectives for my study. The first objective deals with fabricating of the samples, and also to formulate an experimental procedure for the testing of bituminous mixtures using dynamic shear rheometer, and to also investigate the influence of torsion on the viscoelastic response of the bituminous mixture at different test temperatures, frequencies, and strain amplitudes. And further, to map the corresponding response with that of the constituents of the bituminous mixture, such as binder and mastic, and also with bituminous mixture in uniaxial tension or in the axial loading conditions. For this study, I will be using one mixture and 3 different binders and 2 different kind of specimens. And the sphygmoidal specimen which is used in the study is adopted from ASTM standard, where it talks about the linear viscoelastic properties of bituminous mixtures in shear, which needs to this standard needs a complete relook into, and we wanted to explore further into that. And the test temperatures would be from 10 to 15 degrees, and the frequency is adopted from 1 to 10 hertz. The likely deliverables from this work would be development of an understanding of non-linearity of bituminous materials based on geometric and mechanistic principles, and also a test method to compute linear viscoelastic properties of bituminous mixture, which to make sure that there is no other forces and ensure there is only pure torsion occurring on the samples. And finally, to construct a shear modulus based master curve for the bituminous mixtures. The methodology is pretty straightforward, and it involves the use of binder, mastic, and mixture, and the investigation of the same in the dynamic shear rheometer, and delineating the linear viscoelastic and non-linear viscoelastic ranges, and to use a constitutive model, and further to map the responses across different constituents and also with bituminous mixture in different loadings. The important milestones are fabrication of bituminous mixture samples, which is a tedious task in the start, where we wanted to obtain a representative sample as well, and further to use the samples obtained in the dynamic shear rheometer and conduct the test in a manner in a required manner. And there are 2 milestones which are yet to be achieved. One is constitutive model identification, and the other is use of tension torsion model for the bituminous mixture. This is the work performed till now. We have fabricated bituminous mixture samples of smaller size. For this fabrication, we have started with first compacting the bituminous mixture in shear box compactor. The obtained sample from shear box compactor is sliced into the 4 different smaller samples, which of size 63 mm, 50 mm, and 38 mm. And further, this was used for fabricating a smaller sample required for the testing in torsion. And these cylindrical samples are obtained from a gyratory compactor, and they're cored to the required diameter. For the samples obtained for the mixture fabricated, we have conducted a damage test to to test for the damage at lower temperatures of 20 and 25 degrees. This is basically fatigue damage. And these tests and at a strain amplitudes of 0.0005 and the maximum strain amplitude of 0.008% at 3 different frequencies of 1, 5, and 10 Hz. A further large amplitude oscillatory shear analysis was carried out on the results obtained. And these are the different kinds of analysis that were carried out. The first and foremost analysis is the Fourier transform analysis, wherein the higher order harmonics were obtained. And these higher harmonics will give us an idea about the damage that are occurring in the material with repeated loading happening on the material. And we have also computed the energy dissipations based on the Lissajous plot. Lissajous plot explains is a plot between stress and strain as a loop cycle for the sinusoidal loading, and the area of the Lissajous plot between stress and strain gives us the dissipated in a energy dissipation in a cycle. This was used for the analysis and computing the fatigue life further. And based on this, there are certain publications planned. One first publication is to discuss about the linearity limits for the bituminous materials, and the second, which is all under review. And the second one is about the rheological investigation of bituminous mixtures using dynamic shear rheometer. And the third is to construction of shear modulus based master curve. And the fourth one is to correlate the viscoelastic response across different constituents and also the different mixtures with different loading conditions. Thank you.
Thank you, Sandeep, for this nice presentation. Now the floor is open for queries. Actually, I have a query. Since the topic is new to me, can you explain what is the acceleration, deceleration that you presented, the motivation of the study?
So can you hear me, right?
Yeah.
So generally, when the movement of traffic on the roads, the vehicles do accelerate, and there are braking that happens regularly. So when we have these things, this will actually cause a horizontal traction on the surface of the pavements. This generally results in top-down cracking in the bituminous pavements as well. So because of this, we wanted to consider even this horizontal tractions for the next characterizing these materials. So I was telling about that one, normal acceleration, deceleration of vehicles.
Which is not currently included in the design.
No, whatever right now, the experimental methods that we use now, we are only using this vertical load as a criteria, where we also have consider shear stresses. We don't consider the shear stresses and all. We only consider the vertical load, and all the designs are based on only vertical load.
Okay, thank you. You can unmute yourself or you can post the questions in chat box. Okay, if no more questions, we can move to the next presentation. Okay, the next presenter of the day is Mrinal.
Hello everyone, welcome to my video. I am Mrinal Bhumik. I am a PhD candidate in the Department of Civil Engineering, Indian Institute of Technology, Madras. Here I am working under the guidance of Dr. Tarun Naskar. In this video, I will share with you my recent work on the determination of shear velocity profile of layered media using surface wave analysis. Here is the outline of this presentation. First, the introduction. In this part, I will briefly introduce the research background and the basics of the surface wave analysis, existing challenges, and the motivation of my work. Now, the near surface refers to the top few 10 meters of the subsurface, where most of the modern infrastructure such as road, buildings are constructed. And the near surface imaging means determination of the velocity profile and the soil properties. Depending on the type of the velocity profile needed, there are different type of technique, such as P wave velocity can be obtained from the first arrival of the time of the refracted wave. Again, from the shallow reflection test, we get the layering image and the information of the fault. For the S wave velocity profile, we generally use the surface wave such as Rayleigh wave and Love wave. In this study, we focus only the S wave velocity profile, which is a critical parameter in seismic site response analysis. There are other applications also, such as near surface hazard analysis, rock bed durability analysis, monitoring risks during the construction, etc. Here is the propagation mechanism of various type of waves. We can broadly classify the seismic waves into two groups. First is the body wave, which include the P and S wave, and the surface wave, which comprise of the Rayleigh and Love wave. As you can see, in case of Rayleigh wave, the particle motion is retrograde elliptical near the surface, and the amplitude is decreasing with the depth. And most interesting part is that the Rayleigh wave can travel longer distance compared to the other waves. Here is the processing workflow of the surface wave techniques. First, the data acquisition. In active survey, we generally generate the seismic waves by using sledgehammer or in a drop hammer. And for passive analysis, we use the ambient urban noises. Here is the data acquisition system and the geophones. The geophones are the coil magnet system where the coil oscillates around this magnet and create the electric signal we collect into this data acquisition system. Here is one MSW test in our ITM campus. The next step is the dispersion. Seismic source generates wave with different frequency. The high frequency short wavelength waves remain near the surface, and the low frequency long wavelength travel to the deep of the ground and carry the information of the deeper surface. Finally, we captured them in the seismogram. This seismogram contains all the subsurface information, and we have to extract them. One of the way of the extraction of the shear wave velocity information is the dispersion analysis. The concept is similar as when a white light passes through a prism, it gets split into several waves. Similarly, here also the frequency content in the seismogram is separated in terms of the phase velocity. Here, instead of this prism, we use several types of Wavelet transformation technique. And finally, the most critical stage is the inversion, where the peak dispersion curve is iteratively matched with the theoretical dispersion curve, and finally we will get the shear wave velocity profile. Now, the motivation behind this work. The main attraction of the surface wave analysis is they are non-invasive, time efficient, and the environment friendly. It provides us the subsurface information without physically exploiting it. But the main problem is the inverse analysis is ill-posed, and the solution it provides is inherently non-unique. This leads to situations like sometimes in field, predicted solution do not match with the actual profile. This ambiguity in the VS profile impacts the subsequent analysis. It should be mentioned that most of the available commercial software use only the fundamental mode based on the local search algorithm, which perform well in regularly dispersive media, but for irregularly dispersive media, the problem of non-uniqueness increases. So, in view of the problem, one step toward a more accurate and realistic VS profile is the advancement of the inversion algorithm. This is how the overall method will work. For the data acquisition system, we have the 4.5 Hz and 2 Hz geophone and the several multi-channel records. And for the data processing platform, we use only the MATLAB coding, and then the dispersion imaging, and the forward and the inversion algorithm, and how the method will work. Now, the work done. In this part, I will briefly discuss some of our research works. Now, the elastic wave field modeling. For modeling of the complex soil profile, here we used an advanced finite difference based numerical method called standard staggered grid finite difference. Here first the elastodynamic wave equation is written in terms of the velocity stress formulation, and then we discretize the domain in staggered grid manner. Actually, the whole scheme is very difficult to discuss within this stipulated time period. So as an example, here is the comparison between the wave propagation mechanism in single layer half space and a 2-layer system using this standard staggered grid scheme. From the wave nature near the surface, it is clear that the wave become dispersive in 2-layer system. Finally, if we plot the virtual geophone record in this, it is clearly represent the dispersive nature of the Rayleigh wave in case of this 2-layer system. Now the main advantage of this method is it can model accurately any type of it can model any type of complexity, like any regular profile, presence of lateral heterogeneity, presence of any anomalies, any undulation in the profile, and the 3D models. Now coming to the free mode calculation. As you know, vibration of string and beam possess several modes depending upon the frequency and the energy. Here also, Rayleigh wave may propagate in different modes. Theoretical mode are calculated by solving the soil layer system. Here we reviewed most of the available methods which can broadly classified into two groups. First is the root search method, and another one eigenvalue based numerical methods. Here the root search methods, this root search method work by solving the Rayleigh wave equation. This Rayleigh wave equation, which is a function of frequency, phase velocity, layer parameters, vectors. Now, taking the various combination of this frequency and phase velocity, it generates a dispersion function surface, and finally we will get the dispersion graphs. To get a very accurate result, we have to increase the resolution of this frequency and the phase velocity, which is again computationally not efficient, because especially for global search technique, we have to perform this further modeling operation several thousand times. So we need a very time efficient technique. Here we have applied one non-uniform accelerated root search technique which improve the accuracy, as well as the method is also time efficient. Now coming to the another method, that is semi-analytical finite element method, originates from the work of Leismer. Here we solve the governing wave equation and discretizing in one direction, that is we discretize in the z direction and use the available analytical solution in the x direction, and finally we will arrive at the quadratic eigenvalue problem. Actually that's why this method is also called semi-analytical method. Here this A, B, G and M, these are the block tridiagonal symmetric matrix, and this depends upon the only material parameters. So, but the problem of this method is it cannot model accurately the elastic half space, and the conventional way of the modeling of elastic half space is taking a large number of layers to model the elastic half space. Although we have the available elastic half space matrix equation, but we cannot simply add it into this eigenvalue problem, because the parameter k, that is the wave number, that is hiding inside the roots, and we cannot take out and make it as an eigenvalue problem. But in this study we have modified this elastic half space equation, and now we can implement it into this quadratic eigenvalue problem, and we can solve it easily as an eigenvalue problem. So here this outcome look like in the figure A, it is the conventional lumped mass approach and the conventional way of representing the elastic half space by using a large number of layer. But in our case, we have replaced a large number of layer by only a single 2x2 vector, and it gives the very efficient results. Now coming to the inverse analysis. So we have seen from the last slide that how the further modeling works. The inverse is just opposite. From the dispersion curve, we have to predict the soil layer system. And this is how this inversion algorithm work. The blue line is the field observed dispersion curve, and the red line is the theoretical dispersion curve, and it is try to matching, and the final outcome is the Sierra velocity. Here we have developed one fundamental mode-based inversion algorithm and applied on several synthetic and the field data. As an example, we have virtually conducted one MSW test on this 3-layer system using our developed finite difference scheme, and using the field dispersion image, and we perform inverse analysis using our code, and finally the results shown here match well with the actual profile. The mismatch due to we have actually blindly predicted the 4 layer by using 10 layer without using any prior information. We have also included the higher modes in our inversion algorithm, and the predicted Sierra velocity profile, including the higher mode, is slightly better than only the fundamental mode. Now the conclusion. The surface wave analysis is a cost-effective, time-efficient, non-destructive method which provides the subsurface information without physically exploring it. In this project, we have developed a staggered grid finite difference scheme which is capable in modeling complex layered soil profile. We also have compared several further model algorithms and applied a accelerated root search scheme which increased the computational efficiency of this method. A fundamental and higher mode based inversion algorithm has been prepared which perform well in several synthetic and as well as in field data, although the higher mode based code is still under improvement. Here is the instrument of our IIT Madras wave propagation lab. We have used it in this field study. Thank you for watching my video.
Thank you, Mrinal, for the nice presentation. The floor is now open for queries.
Hi, Mrinal. Anil Kumar here. Mrinal, maybe it's not my area of research. You can hear me, right? Yeah, it's not my area of research, but yeah, I have a small question I want to ask. So what is your end product? What you're going to propose in the final stage? So what will be the output?
So answer this question. This is something related to the motivation. So okay, I will answer in just two stages. First of all, the method itself. This method is highly non-invasive. So we will get the subsurface information without physically exploring it. So it is very time efficient. But now in this research, what we are trying to do, we are trying to improve this method. And other thing also, this technique has just two stages. In the first stage, we collect the data from the field, and the second and the main stage is to analyze the data. Currently, to analyze the data, there are only 3 to 4 commercially available software, which are also from supplied from foreign. But in our country, although we have we are bearing 1/6 of the world population, we do not have any data processing software. We rely on the other countries. So one of the goal of my project also that after successfully completion of this project, I will try to make it free for all. I will upload in our ITM website for open source.
Okay, yeah, thank you.
If no more queries, we can move to the last presentation of the day. The last presenter is Reshma.
A warm welcome to all. I am Reshma R., PMRF Research Scholar, working under the guidance of Dr. Somendranath Curie in Environmental and Water Resource Engineering Division of Department of Civil Engineering at IIT Madras. Today, I am here to brief my research on the topic Understanding of Urban Flood Dynamics through Experimental and Numerical Investigations. Human interventions with nature have drastically affected the inherent powers of self-healing and re-establishing a stable and sustainable environment following a natural disaster. Pluvial and fluvial urban floods have become quite frequent with the increased urbanization, subsequent increase in impervious areas, population expansion, climate change scenarios, and high intensity short duration rainfalls. Among all the natural disasters, flood is the most catastrophic in nature. It creates a havoc situation which may take even years to subside. A fluvial flood is caused primarily by the riverbank overtopping accompanied by a high intensity short duration rainfall. Pluvial flood, on the other hand, is caused primarily due to the surcharge from the drainage system causing overflow onto the adjacent streets. The intensity of damage caused and the expenses incurred to restore a normal life following a flood event points out the requirement of a better flood management, forecasting, and damage reduction methods. Also, most of the Indian floods falls under the category of pluvial cum fluvial flooding scenario. Hence, there is a high requirement of better understanding of flood flow dynamics of an urban flood event caused by a combination of riverbank overtopping and drainage surcharge. Though numerous mathematical models are available for urban flood simulations, lack of urban flood data for validation and calibration of those models creates difficulty in their execution. Lack of knowledge regarding the hydrostatic and hydrodynamic forces on the urban structures and their response also leads to difficulties in flood damage assessment and management. Objectives formulated for the research, depending on the literature review conducted, are as follows. To generate high-resolution digital elevation model of the river network urban floodplain setup using the photogrammetry technique, to analyze the flow and inundation pattern induced by a combination of river overtopping and drainage surcharge over an urban area, to observe and analyze the magnitude of hydrodynamic and hydrostatic forces exerted on the buildings by an urban flood for failure analysis, to analyze the experimental data in an available flow model and hence to assess the surface sewer and river floodplain flow interaction during steady as well as unsteady flow conditions. Scope of the work: a laboratory setup incorporating river network urban floodplain system, buildings, drainage network, and other microtopographical features such as road networks, a mechanism to simulate surface sewer flow interaction together will be first of its kind. Experimental study in such a complex setup will give a pragmatic view of real-world flood scenarios. Data collected from the study will serve as a good repository of benchmark data for the validation of various urban flood simulation models. A knowledge of the urban flood dynamics, including the flood flow evolution pattern under the influence of varied building alignments and the flood impact on the buildings, helps in better flood forecasting, damage mitigation, and management. Expected outcomes or likely deliverables from the research are: a good repository of flood data set of an urban flood event caused by a combination of riverbank overtopping and sewer hole surcharge will be generated. An economical and convenient to use methodology for the generation of digital elevation model will be proposed and evaluated. Quantitative and qualitative assessment of flood impact on buildings will be assessed. A better understanding of the flood flow evolution under the influence of buildings will be carried out. Surface sewer and river floodplain flow interactions under steady and unsteady flow scenarios will be assessed. Methodology that will be adopted for the research is as shown in the flow chart. Both steady and unsteady flooding condition will be assessed along with the normal river flow condition. For the purpose, initially, a high-resolution digital elevation model will be developed using image processing and photogrammetric techniques with the help of overhanging DSLR cameras, laser distance and angle meters, total station, and other ground survey techniques. Fluvial, fluvial cum pluvial, and pluvial flooding scenarios will be assessed. The data will be collected using ultrasonic water level sensors, acoustic Doppler velocimeters, large-scale particle image velocimetries, particle tracking velocimetries, pressure sensors, and flow meters. Flow velocity, flow depth, inundation extent, hydrodynamic and hydrostatic force on buildings, and the flow interactions will be assessed for both steady and unsteady flow conditions. However, in the case of unsteady flow condition, since it is difficult to experimentally collect the data regarding the flow interactions, the same will be carried out in the numerical model study. All the data collected along with the developed high-resolution them will be fed into the numerical model and will be analyzed. As a final step, flood hazard mitigation and management strategies will be proposed pertaining to fluvial cum pluvial, and pluvial flooding scenarios in an urban area. Experimental and modeling schemes that will be adopted in the research are as shown in the table. Fluvial, pluvial, and pluvial cum fluvial flooding scenarios will be assessed for both steady and unsteady flow conditions. Fluvial scenario will be assessed with and without buildings. For all the other conditions, buildings will be used in the setup. Flow velocity, water level, river floodplain flow interaction, pressure force on buildings, and surface sewer interactions will be observed in the experimental runs as well as will be simulated using the numerical models. Important milestones in the project: planning, design, and construction of the river network urban floodplain setup, procurement of necessary instruments and sensors, generation of bathymetry of the setup, conducting the experimental runs for both steady and unsteady flow scenarios, numerical simulation of the experimental runs, analysis and interpretation of the results. Progress of research. So far, we have conducted a basin scale investigation on urban floods and causative factors, primarily for the Chennai Basin. An investigation has been carried out regarding the common building alignments found in the Indian cities. Planning, designing, and construction of the setup have been completed. Various instruments required for the study were purchased and tested for accuracy and performance evaluation. Also, a trial run was carried out to ensure that required urban flooding scenarios can be replicated as expected. A schematic representation of the setup is as shown in the figure. The blue color region represents the river network with adjacent floodplains, with urban area in one of the floodplain. An enlarged view of the urban area with different building alignments is shown in the slide. All the square and rectangular blocks represent the buildings. The area encircled in the red circles represents the sewer maintenance holes or manholes, and the crow's path represents the drainage network. The slide shows the stages of construction. These are my publications. One review paper is under review in Measurement Journal. One paper is under review in the proceedings of First International Conference on River Corridor Research and Management conducted by IIT Jammu. 2 abstracts have been accepted by Hydro 2021 International Conference and EWRI 2022 World Environmental and Water Resources Congress. Another abstract has been submitted and is under review with Roorkee Water Conclave 2022. This is our proposed work plan. Physical model has been set up. Research proposal will be tentatively given by the end of this semester. Experimental study and data acquisition will be carried out in this and coming up semester, which will be followed by the data analysis and interpretation. Numerical simulation and analysis will be carried out in the even semester of 2022 and odd semester of 2022, followed by the results and inference, as well as the research colloquium. Communicating to journals and conferences have already been initiated and will be continued till the end of fourth semester 2023. Synopsis and thesis are proposed to be submitted by the end of odd semester 2023. Thank you.
Thank you, Reshma. Now the floor is open for queries.
Hello, Reshma.
Hello.
My name is Shiva Purman.
Hi, Shiva.
It was a nice presentation. I have a question for you. So, in one of the objectives, I remember seeing that you would quantify the amount of forces that would be coming due to the flood waters, right? The hydrostatic and hydrodynamic forces that would be coming onto the buildings due to the flood water. So is it the major cause of destruction in buildings, or is it because the soil gets scarred, like it gets eroded, and hence that causes more damage to the buildings because we lose the basement and we lose everything, right? So what I was thinking that it is a foundation thing which is causing more damage to the building, but which is the case as you see?
The case is like both soil factors as well as the water force, both will have an impact on the buildings. The impact will be different as such, because in the case of soil case, maybe it may cause a sinking of building or what do you call, differential settlement of the building. But in the case of the forces applied by the water, it will be on the directly on the walls, like the supporting part of the building, it will be affected, and it can also cause other what do you call, weakening of the structure and all from the top portion of the building, not from the basement. Also, it depends upon the duration of the flood event, that is how long the water is being stagnated in a particular place. That also will affect the forces, hydrostatic as well as the hydrodynamic forces that is being imposed on the building. So I think that is to be considered along with the soil factors.
So are you going to also consider the soil factors?
No. In our research, it will be purely hydraulic related. That is only the water related impact will be considered. Only the flood, only the hydrostatic as well as the hydrodynamic forces will be analyzed.
Okay, and the forces would also depend on which portion the building is in, right? Which
yes.
So
yes,
would you be quantifying the distance from the source of water flow, or where it is exactly located, and what is the height, and how would you be able to quantify the forces that are coming onto a generalized building?
Actually, for that we have initially we have conducted a study regarding the like the standard type of buildings and alignment that is found in Indian cities, so that we can design the buildings as such, so as to get a exact representation of the Indian scenario during a flood event. Like we will be considering the scaling factors, like the dimension of the building in the actual scenario we'll be scaling down. Similarly, the positioning will also be done on that basis.
Okay, and what is the scale factor that you are taking?
We have not decided that yet. We have just completed the construction of the setup now. So now we have to run the experiments without the buildings first. Then only we have to come to the buildings.
Okay, because you had showed a photo where you had actually shown the work in progress, right? So
yes.
There you have scaled your model?
No, that is actually what do you call, distorted scale model kind of. It is not an exact scale, because if we go for an exact scaled model for the river urban plain setup, the size of the buildings or the flow area will be too small. Then we won't be able to measure the flow pattern or the flow depth as such. Or otherwise, we should have to go for a very large construction, which is not possible in our funding.
Yes. Right. Okay. Okay, thank you. Thanks for the presentation.
Thank you.
If no more queries, we can end the session. So I thank everyone for joining the day 3 of PMRF Symposium 2021. I thank the participants and the attendees and the presenters. So let's meet tomorrow at the same time for day 4 of PMRF Symposium. Thank you all.